Becoming a military pilot's no simple task. The journey demands rigorous preparation that extends far beyond classroom instruction or basic simulation. While flight simulators provide essential experience in handling controls, managing systems, and dealing with emergency situations, they cannot fully replicate the complexity and pressure of real-world flying. For this reason, actual flight time remains a critical component in the development of skilled military aviators. For nearly 100 years, branches of the military have relied on training aircraft to bridge the gap between simulation and combat. These aircraft are instrumental in teaching novice pilots everything about fundamentals and flying techniques to advanced maneuvers. The evolution of training jets mirrors technological advancement and shifting strategic needs. In the early years of military aviation, surplus combat aircraft were often repurposed for training purposes. Among these, the P-51 Mustang stood out. Originally a legendary World War II fighter, several variants of the Mustang were adopted for pilot training. Two-seat versions of the aircraft were especially useful in helping instructors guide new pilots through the intricacies of flight control and formation. Over time, as jet aircraft became the standard, the P-51 became obsolete in terms of combat relevance. It transitioned to a symbolic relic, featured at air shows and in restoration efforts rather than active service. Nonetheless, it retained an honored place in military heritage, particularly due to its association with the Tuskegee Airmen, the first all-African American fighter squadron. These airmen, known for their distinct red tails painted on their Mustangs, broke racial barriers during World War II. Their courage and determination continue to inspire the next generation of military pilots. The turn of the 21st century marked a pivotal shift in how the Air Force approached pilot training. With modern combat aircraft such as the F-22 Raptor and F-35 Lightning entering service, it became clear that existing training jets were no longer adequate for training. In response, the U.S. Air Force launched the TX program in the early 2000s, aiming to redesign the field as state-of-the-art training jets that could effectively transition trainees into advanced fighters. This initiative culminated in the creation of the T-7 Red Hawk, a collaborative effort between Boeing and Sweden Saab. The T-7 is a tandem-seat, single-engine jet designed from the ground up with advanced digital engineering methods. This allowed for highly precise manufacturing, reducing production times, and ensuring components fit together seamlessly. Its introduction marked one of the first major uses of digital design in military aviation, showcasing the potential for faster innovation cycles and lower long-term maintenance costs. The T-7 Red Hawk isn't just modern in terms of production. It's also highly capable. Unlike traditional propeller-based trainers, the T-7 can fly at supersonic speeds, thanks to its General Electric F404 GE103 afterburning turbofan engine. This capability allows trainee pilots to experience flight conditions that closely mirror those of real combat jets. Additionally, the aircraft's cockpit and control systems are modeled to emulate those found in operational fighter jets, providing an ideal stepping stone for students advancing to frontline roles. Importantly, the T-7 pays homage to both the P-51 Mustang and the Tuskegee Airmen. The name Red Hawk and its tail design are direct tributes to its iconic red-tailed Mustangs flown by the trailblazing African-American pilots. The Air Force's choice of this by the name serves as a symbolic link between the past and future of the American military aviation. While the T-7 Red Hawk represents the future of pilot training, it's not the Air Force's first foray into supersonic training aircraft. That distinction belongs to the Northrop T-38 Talon, which first took to the skies in 1959. As the world's first supersonic trainer, the T-38 revolutionized pilot education by allowing students to train at speeds comparable to combat aircraft in the era. Powered by twin General Electric J85GE5A turbojet engines, the T-38 can reach speeds up to Mach 1.3, making it fast enough to stimulate a wide range of real-world missions. Over its lengthy service life, it can be used not just by the Air Force, but also by NASA for astronaut training and test pilot programs. Its readability, performance, and versatility have helped it remain in active use for more than 6 decades. However, the T-38's longevity comes with challenges. Most airframes are between 50 to 70 years old, making regular maintenance and modernization essential. Over the years, numerous upgrades have been applied, from advanced avionics and improved cockpit layouts to engine enhancement. The most recent iteration, the T-38C, features digital displays and systems that align more closely with those in modern aircraft. Despite these efforts, the aging airframes are showing their limits. That's why the T-7 Red Hawk is being introduced as a long-term replacement, ensuring the new generation of pilots can train on aircraft that meet the demands of future warfare. In addition to upgrading its fleet of trainer aircraft, the Air Force has also modernized its educational methodology. Launched in the late 2010s, the Pilot Training Next initiative aims to rethink how military pilots are taught, placing an emphasis on immersive, technology-driven learning. PTN integrates virtual reality, artificial intelligence, and advanced simulation tools to create more personalized and efficient training programs. Students are exposed to mission scenarios using virtual cockpits and headsets, allowing them to practice responses to complex situations before ever stepping into a real aircraft. This approach not only saves costs, but also accelerates the learning curve by allowing students to practice endlessly in a controlled environment. The PTN program has shown promising results, with trainees achieving milestones like first initial solo flights than in their traditional programs. The adaptability of the system allows instructors to tailor lessons to individual needs. When the Air Force focuses on high-altitude supersonic flight, the U.S. Navy has unique training needs of its own, particularly when it comes to aircraft carrier operation. Landing on a moving ship at sea requires exceptional skill and precision. Recognizing the need for specialized training, the Navy introduced the T-45 Goshawk in the late 80s. Derived from the British Bay System Hawk, the T-45 is a jet trainer modified specifically for carrier-based operation. Its design supports catapult launches and arrested landings, mimicking the experience of flying Navy fighters. The T-45 is smaller and more cost-effective than full-size combat jets. The most advanced version, the T-45C, comes equipped with a glass cockpit and updated avionics, bringing the training experience in line with modern expectations. The Goshawk continues to play a crucial role in preparing Navy and Marine Corps pilots for the rigors of carrier operation. Though it does not offer vertical takeoff like the AV-8B Harrier, its flight characteristics provide a close enough match. The evolution of military training aircraft underscores a consistent theme: continuous adaptation. From the iconic propeller P-51 to the supersonic T-7 Red Hawk, each generation of aircraft has addressed specific needs and demands. The Air Force and Navy's dual investment in both legacy systems like the T-38 and T-45 and next-generation platforms like the T-7 and PTN simulators highlight a comprehensive strategy. Rather than relying solely on one solution, they have created a multifaceted training ecosystem that emphasizes safety, efficiency, realism, and adaptability. As threats become more sophisticated and the operating environment more dynamic, future pilots must be prepared to operate in contested, high-tech, and multi-domain scenarios. Achieving this readiness depends not only on their natural aptitude or the quality of their instructors, but also the tools and systems used to train them. In the end, military flight training is not just about mastering an aircraft. It's about building confidence, resilience, and the decision-making skills necessary for success in high-stakes missions. By combining innovation, tradition, and strategic foresight, the United States continues to produce aviators capable of defending its interests and honoring the legacy of those who came before them.